And you are watching Join for Education. In this class, I am going to solve the questions of surface area and volume, class 10 and subject mathematics. This class will be useful to the schooling students of class 10 of cbse board and all boards having medium of instruction is English. Let's start the class. This is the first question of exercise 12.1. I am going to read the question number 1. Two cubes each of volume 64 cube centimeter joined end to end. Find the surface area of the resulting cuboid. To understand and solve the questions easily, let's draw the relevant figure. Let's see here. So this is the first cube and this is the second cube. Both are joined end to end. So the length of the resulting cuboid will be, let's see from question, it is clear that volume of the cube is 64 cube centimeter, which is given in the question, and we know that length of the use of the cube of the cube root of the volume of the cube. So cube root of the volume of the cube is 64 and the cube root of the 64 is the 4 centimeter. So the length of the edge of the cube is 4 centimeter. So length of the resulting cuboid will be 8 centimeter and breadth will be 4 centimeter and height will be 4 centimeter. So the resulting cuboid has we have length, breadth and height. So for resulting cuboid, length is 8 centimeter, breadth is 4 centimeter and height is 4 centimeter. So surface area of the resulting cuboid, we recall the formula. Formula is here: 2 whole stud length into breadth plus breadth into height plus height into length. So now putting the values of L, B and H, then we get here equal to 2, 8 into 4 which will be 32 and 4 into 4 will be 16 and 4 into 8 equal to 32. After the addition we get here 32 plus 16 plus 32 equal to 80 and 80 into 2 equal to, we get here 160 and unit of the area is the centimeter square. So I have written here 160 centimeter square. So this one will be the answer of this question. However, there is no problem to understand the solution of question number 1. Let's see the question number 2. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. To understand and solve the question easily, let's draw a relevant figure. Let's see here. So this is the cylinder and this is the hemisphere and this is the total height of the vessel, which is 13 centimeter and the diameter of the hemisphere is 14 centimeter. Therefore radius will be 7 centimeter. Therefore the cylindrical part, height of the cylindrical part will be 13 minus 7 equal to 6 centimeter. Let's see. From question it is clear that radius of the cylindrical part equal to hemispherical part, and radius is generally denoted by r, therefore r equal to 14 by 2, diameter by 2 equal to 7 centimeter. Half that there is no problem to understand up to this step. So height of the cylindrical part equal to height of the cylindrical part is generally denoted by h, therefore h equal to 13 total height minus the radius of the hemispherical part. So 13 minus 7 equal to 6 centimeter. Hope that there is no problem to understand up to this step. Uh, Inner surface area of the vessel equal to CSA of this part plus CSA of this part. So CSA of cylinder plus CSA of hemisphere, and we know that we recall the formula of the CSA of cylinder is 2 pi rh, and CSA of hemisphere is 2 pi r square. We take 2 pi r common, then we get here r plus h. Hope that there is no problem to understand up to this step. Now putting the value of pi r and h, so we write down here 2. The value of pi is 22 by 7, and value of r is 7, and here r plus h equal to 7 plus 6. So we cancelled out this 7 7, then we get here 2 into 22 equal to 44, and addition of this one is 13. So 13 into 44 equal to 572 centimeter square. So this is the answer of question number 2. Hope that there is no problem to understand the solution of question number 2. Let's see the question number 3. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. The total height of the toy is 15.5 centimeter. Find the total surface area of the toy. To understand the question and solve the question, let's draw a relevant figure. Let's see here. So this is the hemispherical part, and this is the conical part. So total height of the toy is the 15.5 centimeter. Therefore the height of the cylindrical part will be, radius is 3.5 centimeter. So height of the cylindrical part will be 15.5 minus 3.5 equal to 12 centimeter. Hope that there is no problem to understand up to this step. So from question it is clear that, let's see here, radius of the conical part equal to hemispherical part, and radius is generally denoted by r, therefore r equal to 3.5 centimeter from the question. And height of the conical part, which is generally denoted by h, equal to 15.5 minus 3.5 equal to 12 centimeter. To find out the total surface area of the toy, we need the CSA of the conical part and CSA of the hemispherical part. So slant height, to find out the CSA of the conical part, we need the slant height of the conical part, which is generally denoted by L, and we know that slant height of the conical part equal to r square plus h square over root. The value of r is 3.5 centimeters, so I have written here 3.5 centimeter square, and plus The value of h is 12, so I have written here 12 square. So after the simple calculation, a square of 3.5 is 12.25 and a square of the 12 is 144. After the addition we get 155, sorry, 156.25 over root. So the square root of this one is 12.5. So the salient height L of the cone is 12.5 centimeter. So TSA of the toy, total surface area of the toy, equal to CSA of the cone plus CSA of the hemisphere. Now we recall the formula. So CSA of the cone is pi RL and the CSA of the hemisphere is 2 pi r square. So we take pi r common, then we get here L plus 2r. Hope that there is no problem to understand up to this step. The value of pi is 22 by 7. The value of r is 3.5 and the value of L is 12.5 and here plus 2r. So 2 and the value of r is 3.5. So addition of this one will be 7 and 12.5 plus 7 equal to 19.5 and this one cancelled out, then we write down here 0.5 and this one will be 11. After the multiplication we get here 214.5 centimeter square. So the total surface area of the toy is 214.5 centimeter square. Hope that there is no problem to understand the solution of question number 3. Let's see the question number 4. A cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter of the hemisphere can have? Find the surface area of the solid. So this question has two questions. Uh, what is the greatest diameter of the hemisphere can have, and other question is find the surface area of the solid. To understand and solve the question easily, let's draw a relevant figure. Let's see here. So this is the cubical portion and this is the hemispherical portion and this is the total height. So this one will be the suppose length of the edge of the cube is 7 centimeter. So the greatest diameter of the hemisphere will be 7 centimeter. Therefore radius will be 7 by 2 equal to 3.5 centimeter. So let's see. From question it is clear that the greatest diameter of the hemisphere equal to length of the edge of the cube equal to L, which is generally denoted by L, and this is the 7 centimeter. So the answer of 7 centimeter is the answer of this part. What is the greatest diameter the hemisphere can have? Surface area of the solid equal to, here will be total surface area of the cube minus we subtract, this is the circular part, which is pi r square, which is pi r square, and plus 2 pi r square. This is the CSA of the hemisphere. So here will be 6L square and 2 pi r square minus pi r square equal to pi r square. Hope that there is no problem to understand up to this step. So 6l square plus pi r square. Now putting the values of l and r, we get here 6 and the value of l is 7. Therefore, I have written here 7 square plus the value of pi is 22 by 7 and the value of r is 3.5. So I have written here 3.5 to the power 2. So this one will be 49 into 6. So 49 into 6 equal to 294 and here we cancelled out, then we get here 3.5 into 3.5 into 22 by 7. So here will be 10. So 7 5 are 10 and after the multiplication we get this one 38.5. After the addition of these two we get 332.5 centimeter square. So this is the surface area of the solid. Hope that there is no problem to understand the solution of question number 4. Let's see question number 5. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. To understand or solve the question easily, let's draw a relevant figure. So this is the cubical wooden block and this is the hemispherical part cut out from one face of the cubical wooden block. So from question it is clear that the radius of the hemispherical depression equal to r. Radius is generally denoted by r and according to the question r is equal to the L by 2. Edge of the cube equal to L. Surface area of the remaining solid equal to TSA of the cube minus area of circle plus CSA of the hemisphere. Hope that there is no problem to understand the uh, up to this step. So TSA of the cube is 6L square. Area of the circle is pi r square and CSA of the hemisphere is 2 pi r square. So here we get 6L square and 2 pi r square minus pi r square equal to pi r square. So the value of r is L by 2. So I have written here L by 2 to the power 2. So 6L square plus pi L by 2 whole square equal to this one will be 6L square plus pi L square by 4. So I have taken L square by 4 common, then we get here 24 plus pi square on it. So this one will be the answer of the surface area of the remaining solid. Hope that there is no problem to understand the solution of question number 5. Let's see question number 6. A medicine capsule is the shape of a cylinder with two hemispheres are stuck to each of its ends. See in this figure, the length of the entire capsule is 14 millimeter and the diameter of the capsule is 5 millimeter. Find its surface area. To understand and solve the question easily, let's draw a relevant figure, or figure is already given here. So let's consider about the figure. So from question, it is clear that R, or radius of the cylindrical portion as well as the hemispherical portion, which is generally denoted by R, equal to, from the figure it is clear that 5 by 2. So 5 mm is the diameter. So we know that radius equal to diameter by 2. So I have written here 5 by 2 equal to 2.5 mm. Hope that there is no problem to understand up to this step. And here L equal to, L will be 14. Total length is the 14, and we subtract this part. So this part will be 2.5, and this part also will be 2.5. So we subtract 2.5 plus 2.5 equal to 5. So 14 minus 5 equal to 9 mm. So hope that there is no problem to understand up to this step. So surface area of the medicine capsule equal to, from figure it is clear that csa of the cylindrical part plus 2 into a spherical part. So we recall the formula of the cylindrical part, or csa of the cylindrical part, which is 2 pi r l plus 2 pi r s square. This is the uh, csa of the spherical part. 2 pi r l plus 2 into 2 pi r square. 2 pi r common has taken, therefore here we get L plus 2R. So we write down here 2, and value of pi is 22 by 7, value of R is 2.5, and the value of L is 9 plus 2, the value of R is 2.5. So here will be 5, and 9 plus 5 equal to 14, and this one is cancelled out by this one, then we get 7 to the 14. So here will be 220 millimeter square. After there is no problem to understand the solution of question number 6. Let's see the question number 7. A tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the salient height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. So this question has two parts. In first part ask us what is the area of the canvas, and second part ask us what is the cost of the canvas. To understand the question and solve it easily, let's draw a relevant figure. So this is the cylindrical part and this is the conical part. and this is the total height, and this is the slant height. Slant height is given here 2.8, and diameter is 4 meter, therefore radius will be 2 meter, and height of the cylindrical part is 2.1 meter. Let's see the solution. From question it is clear that height of the cylinder, which is generally denoted by h equal to 2.1 meter according to the question, and radius of the cylinder, which is generally denoted by r, 4 by 2 equal to 2 meter. After there is no problem to understand up to this step. Therefore, slant height of the cone from the question, it is 2.8 meter, and rate of the canvas is 500 rupees, 500 per meter square. After there is no problem to understand up to this question, up to this step. Area of the canvas equal to CSA of the cylinder plus CSA of the cone. After there is no problem to understand up to this step. And we recall the formula CSA of the cylinder equal to 2 pi RH, and CSA of the cone equal to pi RL. So the value of pi is 22 by 7, the value of r is 2, and the value of h is 2.1, plus value of pi is 22 by 7, and r is 2, and l is 2.8. We cancelled out this one, then we get here 0.3, and we cancelled out this one, then we get here 0.4. So after the simple calculation, we get area of the canvas is 44 meter square. Cost of the canvas equal to area of the canvas into rate of canvas per meter square, which is rupees 500. Therefore, cost of the canvas of the tent at the rate of rupees 500 per meter square is rupees 22,000. So these two are the answer. This is the answer of the first part, and this is the answer of the second part. After there is no problem to understand the solution of question number 7. Let's see the question number 8. From a solid cylinder whose height is 2.4 centimeter and diameter is 1.4 centimeter, a conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. To understand and solve the question easily, let's draw a relevant figure. So this is a cylindrical part, and this is the conical part. According to the question, this is the conical cavity. So this is the height of cylinder as well as the cone, and this is the radius of the cylinder as well as the cone. So from question it is clear that height will be 2.4 centimeter according to the question, and R of the cone and cylinder according to the question, and we know that radius is the half of the diameter. According to the question, diameter is given here 1.4, so 1.4 by 2 equal to radius of the cone or cylinder, which will be 0.7 centimeter, and slant height of the cone. For the slant height of the cone, we recall the formula r square plus h square over root. So the value of r is 0.7 and value of h is 2.4. So 0.7 square plus 2.4 square over root. A square of this one is 0.49 and a square of this one is 5.76. So after the addition we get here 6.25, and a square root of 6.25 is 2.5 centimeter. However, there is no problem to understand up to this step. Total surface area of the remaining solid equal to 2 pi rh plus this portion pi r square, this part, plus csa of the cone pi rl, pi r common, then we get here 2h plus r plus l. So the value of pi is 22 by 7, value of r is 0.7, and 2 into value of h is 2.4, value of r is 0.7, and the value of l is 2.5. After the simple calculation we get here, we cancelled out this one, then we get here 0.1. 0.1 multiplied by 22, then we get here 2.2, and here we get here 4.8 plus 0.7 plus 2.5. So here will be the addition will be 8. So 2.2 into 8 equal to 17.6 centimeter square. So the nearest centimeter square of this one will be 18 centimeter square. So area to the nearest centimeter square equal to 18 centimeter square. So this one will be the answer of this question. Hope that there is no problem to understand the solution of question number 8. Let's see the question number 9, or this is the last question of exercise 12.1. From question it is clear that h of the cylinder equal to 10 centimeter according to the question, and radius of the cylinder and hemisphere according to the question, this is 3.5 centimeter. However, there is no problem to understand up to this step. So total surface area of the article equal to csa of the cylinder, this part, and csa of the sphere. So we have two uh, hemisphere, so two hemisphere will be a sphere. So here will be we recall the formula of csa of the cylinder is 2 pi rh, and according to the figure we recall the formula of hemisphere, which is 2 into 2 pi r square. We have two hemisphere in this figure, this is the first and this is the second. So here will be 2 pi rh plus 2 pi r square into 2. I have taken 2 pi r common, then here we get h plus 2r. After putting the value of pi, r and h, we get this step 2 into 22 by 7. The value of r is 3.5, the value of h is 10 and 2 and value of r is 3.5. So here will be 10 plus 7 equal to 17. However, there is no problem to understand up to this step. And when this one is multiplied by divided by 7, then we get here 0.5. 0.5 multiplied by this one, then we get uh, 11, and 11 multiplied by 2, then we get here 22. 22 multiplied by 17, then we get 374 centimeter square. So this is the solution of question number 9. Hope that there is no problem to understand the solution of question number 1 to 9. Thanks to watch. Hope that this class will be useful to the schooling students of class 10 having a subject mathematics in English medium of cbse board and all other state board whose medium of instruction is English. So thank you very much to stay with me till the solution of question number 1 to 9. In the next video, I will solve the questions of exercise 12.2. Till then, thanks to all of you. Thank you very much.